Okay, the experiment that we're going to be doing today is going to involve testing the rate of diffusion. And this is Celia, and Celia is going to be doing the experiment. So the first thing that we're going to do is we're going to state the problem. And so Celia, the problem that we're going to be working on today is, does temperature affect the rate of diffusion? And diffusion is when something goes from an area of higher concentration to lower concentration. So we're going to see if food coloring diffuses faster in hot water or cold water, or maybe it's the same. So the first thing we're going to do is we're going to gather information. So if we were going to mix food coloring in two different containers of water, one with room temperature water and one with warm water, would the rate of diffusion of food coloring be affected by temperature? So Celia, what do you think? I want you to predict what you think. Will it be the same or different?
I think it will be different. I think that it will sink in the one with warm water.
Okay.
And then it will sort of float in.
Okay. Alrighty. Excellent. So here's our experiment. We have our materials. We have two glass containers of the same size. We have a thermometer to measure the water temperature. We have food coloring, red and blue food coloring. The timer we're going to use on the phone. And this is 2 cups of room temperature water, and then we have some water that's been warmed, and then you'll just measure it when you're done with that. So we can start right now. If you will measure 2 cups of water, room temperature water, into number 1. Okay. Now, this water's been warmed. If you'll measure 2 cups into there and then pour it into bowl number 2. Here, and I will hold it here for you if that helps. Okay, stop. Let's see. Are we a little over there? Is that a little bit over?
Yeah.
Okay, here. Let's try and make it even. Still a little more? Okay, there you go, 2 cups. So if you'll pour that into bowl number 2. Okay, now will you take the thermometer, please, and measure the temperature of bowl number 1. Approximately, because the numbers I see are kind of tiny, so
About 70.
about 70. Okay, so can you write that next to container number 1? Perfect. 70, and that's Fahrenheit. Okay, then put it in bowl number 2. Okay, what do we got there?
It's about 100.
Okay, climbs pretty fast. Okay, so 100. So we've measured 2 cups of water. In each one, we've measured the temperature, and now we are going to put 5 drops. We'll just 5 drops in this container of red. You want to test it first in here? See how fast it goes. Okay, so you kind of see how you have to do it. Okay, so 5 in there. Then we'll quickly do this one, and I'm going to set the timer. Okay, I'm going to start now, and at 20 seconds, I want you to see what you observe, what you think is happening. So what are you seeing right now?
This one is a little more spread out.
Okay.
And then this one's just sort of going in circles.
Okay. All right, so that's 20 seconds. And we'll wait for 40 seconds. So what are you observing still? What do you think's going on in there?
This one is mixing in faster than this one.
Okay, so the cold water seems to be spreading out more, and this is still sort of in a higher concentration. Okay, so that's at 40 seconds. And then at 60 seconds, you can make a final observation. Okay, so what do you think is still? Is it still kind of doing the same thing?
Yeah.
This one's still kind of pooled at the bottom?
Yeah.
Okay, so that's 60 seconds. Okay, so in general, what did you observe about the cold water?
The cold water, the red food coloring is spreading out, and it's just not staying in one place. It's
Okay.
going everywhere.
Okay, and then the blue food coloring, what do you think, what is going on in there?
It's just sort of stayed at the bottom.
Okay. Okay, so this is sort of more, it's covering more of the bottom. Now, which one, is one still moving and one not moving?
This one is still moving.
So the hot water, it's still moving, the cold water is kind of not moving at all. Right, okay. So which one was faster, which one was slower, which one was the same?
This one was faster.
This one was faster, okay. And this one is still moving. Okay, so if we were to form a conclusion, why do you think that this happened? What would you infer from what you've seen?
Cold water diffuses like faster than the warm water.
Okay, and more evenly? Do you think it's more even? Because this is still kind of in a clump in the bottom?
Yeah.
Okay. Why do you think the food coloring reacted that way it did in cold water? And there's no wrong answer. It can just sort of be, you know, your best idea.
Because cold water, the food coloring is it's sort of about density. Like the food coloring is sort of just as dense because there's some at the top and some
Okay.
at the bottom.
Okay.
And so, and the food coloring for the warm water, it's more dense
Okay.
than
Okay.
the warm.
And we didn't stir it at all, right? So it's just happened all on its own. Okay. If we were gonna apply this to like a real life situation, so if you were to think of this, and if you were, how do you think maybe you might use this if you were making something with water and mixing it with something? What would you do? Do you
Probably
think?
like something like lemonade or hot chocolate.
Okay. Okay. Alrighty. So we stated the problem, we gathered the information, we designed the experiment, we used all the materials, we used all the different steps to investigate, we measured, we observed, we communicated the results, you made an inference of what you thought might happen, and we applied this to a real life situation. Okay, that's our experiment. And of course, are you done?